So this apparatus should be quite familiar to you by now. This is the simple distillation apparatus. So what's been set up here in advance, there's a pear-shaped flask here, just an adapter here with a thermometer at the top. Notice the end of the thermometer at the junction here with the condenser. Here we've got a Liebig condenser. I need to put water in at the bottom and out at the top. Remember to keep it nice and full of water, drive out any air bubbles that are in there. So this is a nice cool surface. Then there's a delivery tube out this side, and in here, notice there's a test tube, but I've got it sitting in an ice bath, so it's a cooled test tube here. More on that a little later on. So there's a nice cooled test tube, which is just sitting there ready to receive whatever it receives. As always, with the simple distillation setup, I'm just going to take this little pear-shaped flask out of the way now. And now that the setup is ready, I know that I can very quickly reattach that to the correct place. Before I do anything else, I'm just going to take some anti-bumping granules. So remember, these are little just ground up pieces of glassware. Doesn't take part in the reaction at all, but it does make sure that any boiling that happens nice and smoothly, so it prevents a big build-up of pressure with everything bumping across. So it just enables smooth boiling because it allows small bubbles to form rather than big bubbles forming. The purpose of this apparatus then is to oxidize ethanol. Now, the first example of oxidation of ethanol is the one that I'm about to do now. I'm going to take from this little beaker some acidified potassium dichromate 6. I'm just going to pour that really carefully because it's not pleasant stuff in the slightest. So acidified potassium dichromate 6 solution into the pear-shaped flask just there. So in the pear-shaped flask, there's some of the oxidizing agent. So the oxidizing agent in this example is acidified potassium dichromate 6. And the aim of this particular setup is to separate out the oxidation product which distills immediately from the mixture. So I've got to act pretty quickly here. I've got some ethanol in this bottle. I'm going to add some ethanol fairly quickly to this flask, reassemble the simple distillation apparatus, making sure that before I start any of this, I've got the water running through the condenser, which I have, and the iced cooled receiver for that. So I'm going to work pretty quickly. How it's going to go is I'm going to add ethanol to here, very quickly stick this back on and reassemble the simple distillation apparatus, and then I can relax a little bit, safe in the knowledge that whatever is being evaporated and boiled in this bit and distilling across is safely being received over here, and then we'll pick up the story. So we take some ethanol. I'm going to go 1, 2, 3, I'll add a 4th one for luck into that pear-shaped flask. Very quickly get the lid back on the ethanol, put that out of the way, get this all attached to the simple distillation apparatus like so. Make sure the joints are nice and secure, which they certainly seem to be, and then I'm okay. That's all nice and safe, and I can relax slightly. I'm now going to put the ethanol well out of the way in the food grid and close that down. I'm just going to make sure that I've wiped up any ethanol that might have just spilt on that bench. I'll just make doubly sure and get rid of that tissue, because the next thing that I would like to do is to light this little mini Bunsen burner, and so it's good practice to get rid of any ethanol from the general vicinity. So I'm going to take this Bunsen burner, I'm just going to give this a little swirl actually, to make sure it's as well mixed as it can be, and to give that a good agitation, give it a swirl, and I'll take this Bunsen burner and get this lit. So the micro burner is now lit. I'm just going to gently heat this. So I'm going to heat and stop heating, heat and stop heating, and so on and so forth. So just gently heat this up so that the temperature on the thermometer starts to rise up, and we should start to see the first of the distillates coming down here in a moment or two time. The boiling point of the first of the distillates that we're expecting should be around about 21 degrees C. So we shouldn't need to heat this too much in order to distill across the product. Just keep going with that, and this is the method of oxidizing ethanol in the pear-shaped flask, but immediately distilling across that product and making sure that the temperature doesn't get too high in this flask to make sure the first product is the one that we distill across. So I've stopped heating now because the temperature on the thermometer has started rising quite steeply and it's well above that 21 degrees C now, so I'll stop heating that up because I don't wish for either the unreacted reactants or other products or indeed the solvent in the acidified solution to start to come across as well. The key point about this, notice that the colour has changed quite dramatically in the pear-shaped flask. Now, it might be quite difficult to see the actual colour here. The textbook change is described as orange to green. This one perhaps looks a bit darker than green from where you're getting it from the angles, but orange to green is the colour change expected. Importantly, this is the product which distills across immediately. Now, I haven't got huge quantities of it collecting in this test tube. There's a little tiny few drops in here, but probably not enough to do a chemical test on those. If we were to chemically test that, the method could then be Tollens reagent or failing solution, which gives you a clue as to which product we are isolating if we do the oxidation followed by immediate distillation. So this is a second example of oxidizing ethanol. This time I've improved the conditions slightly, so I've added more of the potassium dichromate 6 powder and also acidified this firstly with dilute sulfuric acid and then added some concentrated sulfuric acid. So this makes sure that I've got a really good excess of the oxidizing agent in this example. You notice that at the moment I don't have a distillation setup here. I've got what's called a reflux setup. I'll discuss that in a few moments' time once we've got this going. I'm cooling this over ice and I'm just going to add, again, say 3 good pipette loads of ethanol to that, just making sure that I don't overfill that pear-shaped flask. Pop that lid back on the ethanol and then get this one clamped in place like so. So inside here I've got some anti-bumping granules and the acidified potassium dichromate 6 solution. So the acidified potassium dichromate 6 solution in a good excess, some ethanol, you can probably see that reaction's already happening at the top here, anti-bumping granules at the bottom, and this time the apparatus being used here is for reflux, and I'll explain what that means in a moment. I've got a microburner, so I need to light this and start it here, but of course there's some ethanol sitting here which isn't great, so I'm going to move that out of the way so that we've not got any naked flames near that ethanol fume bottle. Sample bottle there, pop it into that fume covered like so. Okay, I'm going to move this out of the way just so that I can light it. I don't need that just now either, so I can move that beaker out of the way also. So just like that microburner like so. There we go. And put that on a nice blue flame. Again, gentle heating, so I'm going to heat gently like this. So heating on and off and on and off like so. And I'll just keep heating that now. Now the idea about this reflux apparatus is that it allows this reaction to take place at the boiling point of the sample in question. So at the boiling point of the sample in question, the sample will boil, the solvent will boil, the vapours will rise up where they'll hit this cold condenser, cool, condense and drip back down. Same again, cool, condense and drip back down. Cool, condense and drip back down. So this allows the reaction to take place at the maximum possible temperature, which is the boiling point of that particular solvent, without losing any vapours of the solvent into the room, and therefore without risking this flask drying up at all. Notice this time, no thermometer at the top here. So it's important that the system is open so that the gases inside that system can expand, and therefore we are not generating by accident an increase in pressure. So the way that this one works is the idea here is to achieve complete oxidation of the ethanol. So the idea is heat and allow that to continue reacting at the boiling point of the solvent in question over a period of time. Of course, what will happen then after this reaction has been happening at the boiling point of the solvent over a period of time is that in the bottom here there will be a mixture. And the mixture might contain, for instance, some unreacted ethanol if we've not gone to completion, the oxidation product itself, but also the water that was used in the acidified potassium dichromate 6 solution should also be in there. And so the final step of this method would then be to assemble the simple distillation apparatus, or even a fractional distillation apparatus would be even better separation, to then separate the final product from the reaction mixture. I'll come back in a few moments when this has had a bit of time to heat. So you might be able to see, if you look really closely here, this has been heating for a little while, that the vapours are rising up, hitting the condenser, cooling down and dripping back down into the flask. And so this could carry on for a period of time, trying to get the reaction to go to as far towards completion as possible, and then take the products, separate those out using other distillation techniques.